Already put up.
Oh, yeah, you're right.
Thank you, sir. I haven't checked it yet, but I'm about to. You have until I finish checking attendance, which requires me to find the attendance book. Say again. It's really okay. All right. Haley is not here. I didn't see her at least. Oh, by the way, good morning, Jamarcus.
Good morning.
Yes, you are. 13. Is he not here? Is he not here? Gosh, he usually tells me ahead of time. It's not here. Rakai? Yeah. Okay. Mickey's not here. 23. Jamarcus. Oh, yeah, you haven't had yours. Hayden. Shania, you haven't had yours in a little bit. Okay. Trayana, I saw her earlier. Has Trayana not come back yet? Okay. Let's get started with today. I'm going to stop the poll. Let's look at it. So, we got quite a few, which you cannot see this. We got quite a few x equals 9s. But notice a whole lot of us, yeah, go ahead and grab it for me, please, thank you. A whole lot of us got 9 equals 0, 0 equals 9, and then what did some people write with this? No solution, okay? Does 0 equal 9? No. 0 does not equal 9. And so that's just not true. Why is it important that I'm bringing up this language that that's just not true? So when we substitute in for x, it's not going to be true because the solution is what, David? Huh? It's not true. So remember, when we solve, we're trying to find a what? Solution. And the only thing that solution means is a value or values that make an equation, that make an inequality true. That's it. So if we get to the end of all this and we get a statement that is false, will anything make that equation true? No. That's it. That's one of the foundational things I want us to see out of this. But I also want to talk through a couple of details based on this bell ringer. So this is some of the fundamentals. And please understand, like, bell ringers are designed for me to be an important teaching opportunity for you to learn ideas. By the way, Trayana, don't forget to put up your phone. Thank you. Important learning opportunities. And so there's two things I want to talk through with the solving process. What was the first thing that most of you did to solve your equation? Raise your hand if you want to share what you did at the start. Go for it, Eliza.
Did 3 times 2 and 3 times 5.
Okay, so 3 times 2, what is that called? Whenever we multiply like this to multiple things, we can distribute. Okay? We can distribute. It's called a distributive property. And so when I do 3 times 2x, what do I get? 6x. And 3 times 5, what do I get? 15. I'm going to pause there though, because I want to point out why this works. Anybody know why we can distribute? Why does that allow me to distribute?
Oh my brain.
So Jose, we talked about it in your group, right?
Mm-hmm.
What did we talk about the focus of this right here is?
It's adding 2 plus 5, 3 10.
What is multiplication, guys?
Repeated
Addition. That has not gone away and it will never go away. When we say 3 times 2x plus 5, we literally mean that multiplication is repeated addition. So I'm adding 2x plus 5, how many times? 3. So often, students don't realize what they're supposed to multiply by, or they don't completely distribute correctly. But if we recognize that that multiplication is repeated addition, how many x's do I now have being added?
3.
Well, how many x's total? Because remember, how many are right here?
1.
2.
Oh, it's 2. Oh, yeah.
Remember, that multiplication here is also repeated addition. That means I'm adding x twice. Then I'm adding 2 more x's. And then 2 more x's for a total of 6 x's. That's why I can just do 3 times 2x to get 6x. How many 5s do I have being added? 3. If I add 5 3 times, I get 15. That's why the distribution works. That's why, right there. Questions about why the distribution can work, going back to that fundamental of multiplication is repeated addition. Now, so it looks like no, looks like we're okay with it. Hayden, focused, making sense of it. Here's the thing, am I ever going to ask you to do this part? No. But it's important to understand that background, that fundamental. This is the reason why when I distribute I have to multiply 3 by both terms. Okay? Because I'm literally adding both terms 3 times. What happened to my good eraser? Second blog just thought they, or second group thought they could just steal my eraser. Rude. Okay, so now looking at this, there's a lot of us, I think, that maybe either added or subtracted 9 on both sides, or added or subtracted 6 on both sides of the equation, or maybe that 15. Does that sound familiar? Okay. Is that legal? Sure, 100%. Personally though, when I see my variable, I'm usually going to start with my variable. Eventually y'all had to subtract 6x, didn't you? And why would I subtract 6x? Because I saw one group where a person added 6x. Why am I not going to add? Okay, I have to do the opposite, but why do I need the opposite? To create a 0. Don't forget that the goal with adding and subtracting is always to create a 0. What does that create? Right here?
12.
That's 12x, right? I have x being added 6 times, I add 6 more x's, that's a 12x, I don't want that. But if I have 6 x's being added now, and I take away 6 x's, I am left with 0. And also 6x minus 6x is, so what is 0 plus 15? What is 6 plus 0? Notice that's very similar to what y'all got. 9, y'all got 9 equals 0, but regardless, is 15 equal to 6? So is that the solution, or is there a solution? No. That statement is false. There is no solution. Nothing could make this equation true. Now, I want to point out one thing about this. Does this equation look the same as this original equation? No. Does anyone know what we call these two equations, though? Starts with an E. Equivalent. They look different, yeah? But are they telling the same story? This has no solution. This has the same no solution. What allows me to create different looking equations that tell, or yeah, different looking but equivalent equations, one, distributive property. That distributive property does not change the equation, just changes the way it looks by distributing that multiplication by 3. Right here I subtracted 6x. So what else did I have to do? I had to subtract 6x on the other side. Hear me very clearly on this. We're not moving anything. A lot of us have heard math teachers and have said it as we're moving the variable. We're not moving the variable. We're trying to create a 0. But if I change the left-hand side of the equation and I want my equation to be equivalent, I have to change the right-hand side by the same amount. That's what's happening there. I'm not moving the x across the equal sign. I'm creating a 0. And what this is called is a property of equality. Whatever you do to one side of the equation, you have to do to the other side. It's called a property of equality to create an equivalent equation. That's the mathematical language there. Okay? What I do to one side of the equation, I have to do to the other to keep those equations equivalent. That's called a property of equality. I'm not moving. Now, this is, again, just an intro. I meant to do pre-assessments, hand those back today, but I'm going to do those notes on Monday. We're going to move into the practice that we started yesterday at this point. What are your questions about the language, the terminology, the concepts before we move to the rest of today's lesson? Remember, guys, this is supposed to be an important learning opportunity, right? This is a great time to actively collaborate during the bell ringer. This is a great time to ask questions. The more you talk, the more you're going to grow and learn. And I can't remember, I know, Cam, you were asking a question in small group time. Did you ever get your question answered? Okay. Any other questions that came up during small group time that I can address? Okay. All right. So let's start with today. Agenda, first things first. That's not what's supposed to be net first. So new groups only for second and third. We did our new groups yesterday. We did not yet this week do our famous black mathematician to celebrate Black History Month. So we're going to start with that. Before I get further though, I did need meaning to introduce Miss Bauer. She is from the University of Alabama. She will be a student teacher or student placement. I don't remember the exact term. What is it? Clinical placement, but yeah. She'll be helping throughout the semester, Monday, Wednesdays, and Fridays for the most part. Mr. Kilpatrick, was that his last name?
Yeah.
Okay.
Yes.
Mr. Kilpatrick will also be with us a lot of Mondays and Fridays. I think was his plan. Does that sound right?
I think so.
Okay. So they're juniors at UA.
That's right. Yeah.
Juniors at UA working on a teaching degree, and so they're going to be here observing how we operate, how we interact to learn how to be a better teacher for the future. But Black History Month, let's look at that. All right, so to celebrate Black History Month, we've been looking at a famous black mathematician each week. Our last one will be on Monday. So we're going over one mathematician every week for the entire month of February. We've already talked about Benjamin Banneker. We talked about Katherine Johnson. Today we're going to talk about Fern Hunt, and then next week, or Monday, Mark Dean. Has anybody noticed a pattern showing up about why these mathematicians got into mathematics? I've tried to mention it, but I know it's been spread out over a couple weeks. What was the motivation to get into math? For Benjamin, remember he was all about, I believe it was astronomy. He was all about looking at the stars.
To understand the world better.
To understand the world better, right? He was able to accurately forecast lunar and solar eclipses based on his work with mathematics and with clocks. Katherine Johnson, right, was passionate about mathematics, and that, but that was paired also with looking at rockets or space shuttles, sending people in to the moon. Again, trying to understand and make sense out of the real world. Fern Hunt. So Fern was the grandchild of immigrants from, I want to say it was Jamaica, but it was one of the Caribbean Isles. And so she grew up in the Hampton housing projects. She grew up in what would be considered the poorest of the poor in New York City. But she fell in love with science early on and transitioned to math in high school. I believe what it said was that not ninth grade, when she was 9 years old, she was gifted a chemistry set for Christmas. And that sparked a love of science and of exploring the world around her. And then that evolved into mathematics when she got into high school. In today's world, she is actually working with applied mathematics in the fields of chemistry and biology. So she's working as a researcher at the National Institute of Standards and Technology, working on mathematical problems for physics and chemistry. And her work has earned her the recognition by Mathematically Gifted and Black as a Black History Month 2017 honoree. So she is still alive, she's still kicking, she's still working. And once again, I want to point out, like, math is not this random thing where someone's like, oh, I just want to study math. That's not what was the motivation. Math is the study of what again? Patterns and relationships. And there's a language with that, but when we look at the natural world around us, when we look at astronomy, when we look at chemistry, when we look at physics, when we look at, name it, there are patterns and relationships, and there's beauty with that mathematics. And Fern went from the poorest of the poor to being Black History Month honoree, working for the National Institute of Standards and Technology because she fell in love with, not saying that she was the smartest in the world, but she fell in love with and she worked hard and she grew in her understanding of mathematics. I greet you every single day when you come in and I ask you to respond with I'm capable, even when we're not feeling it, guys. You're capable not of necessarily being perfect today, but you are capable of growing and learning. But you have to make that choice. Fern Hunt made a choice to pursue mathematics, to pursue biology and chemistry, and it has made a huge difference in her life. I'm here to support you, to chase after that, but you got to make that choice. Let's chase after it. Let's grow and let's learn together. Okay, so there's Fern Hunt for our Black History Month presentation. Next week we're going to talk about Mark Dean. All right. Nope, that's not what I want. That's it. From there, let's get back to today's previously scheduled programming. All right, we're going to be working today on writing equations for quadratic functions. And I know some of us again are like, well, Mr. Kinney, we're not comfortable with quadratic equations, right? This is going to help us practice and learn those quadratic equations better. It's also going to help us prepare for our unit on solving equations. And I've already told you, some of us have done pretty well actually on the test the further I've gotten into them, but a lot of us have a lot to grow still. And when is your last opportunity to show me mastery of linear, exponential, and quadratic functions? Midterm. We've got tutoring hours, and I'm here honestly every morning if you come in and ask questions. The videos are on YouTube of what we did in class. I would never watch the entire video. I would only focus on the timestamp portions with what you have questions about. If your questions are about the forms of quadratic equations and what the pieces mean, find one of the videos that talks about it. We talked about it for days after day, or day after day after day. Focus on one or two that really explain things. All right. So we do want our textbook out. M1-60, I believe, is where we were with our notes. And then we have a sheet of paper. Was anyone not here for this writing quadratic equations yesterday? Why? Oh, you can grab it there. All right, so Treyana, Tyson, and Phoebe. Whoops, I did not grab a sheet of paper. That's supposed to go. Tyson. Alright. I mean, I don't need to sign it, I'm just gonna mark it in my book, okay? Alright, so, can I get a volunteer to read our objective for the day? Lily Kate, go for it. So we want to write the equations of quadratic functions based on key features given. And we've done some background work out of the book. Remember, here are worked examples to help you out on M1-60. If you are given a vertex, this is that example. If you are given roots, there's that example. But the bigger thing I want to focus on is a reminder here. With A, which form did we say we were going to use to write the equation? Why, Phoebe, oh, Phoebe, you weren't here yesterday, so, sorry. Miracle, why did we say we're going to use vertex form for part A?
Because it says minimum.
It says minimum, so minimum means that we have a what? Vertex. Jalen, what form are we going to use for B? You don't have it in your book?
None. Wait, oh yeah, it was factored.
Factored form. Why are we using factored form here, Rakai?
Because it has.
Rakai, Tevin. I'll get you in a second. I'll get you on the next
Nah,
one.
you good. Yeah.
Because of the roots. How do you know you have roots? It doesn't say roots up there. Ah, with our x-intercepts, remember, y is always equal to 0. And hey, what do we call the x values of x-intercepts?
Roots.
Roots, right? Okay, so we have roots given even though it doesn't say roots. Tevin, with C, what did we say?
None.
None, right? We said none. Now I will say this, that is a case where we could use standard form, but am I going to ask you to write the equation in standard form? No. We're only going to be doing vertex form and factored form unless I give you technology, which next Friday we are going to use technology to model some functions when we're given points, and I'll explain all that then. All right, so we already worked through these four. Does that sound right?
Yeah.
Yes? Okay. So here's where we are. We did number 1 together yesterday. Does that sound right?
Yeah, we did.
So we're on number 2. As a quick recap, so I do want to work through this because I believe we just started, we went through this, but there are some of us who missed yesterday. So let's remind ourselves, even though it says one of 2 x-intercepts, which form am I using here?
Vertex.
Vertex form. How many x-intercepts do I need to use factored form? I gotta have both of them. I only have one. But I have vertex, so I'm gonna use vertex form. What is the first thing I always recommend that you do? Write that equation, guys. Take the time. Remember, every time you write that equation, it's gonna give you a chance to remember the equation better. So I'm gonna write that equation out. It's also going to help me focus my attention. Right? Jose, what 3 things do I need to be able to write this vertex form now? I need what? A, H, and K. Do I have any of those already?
Yeah.
Which ones?
Okay,
H is the x value of the vertex, K is the y value. Yes, ma'am? Did you not hold on to it yesterday? Okay, I'll get one for you in just a second. So H and K there. Alright, well I already have the start on my equation. Now we put x plus 2 here yesterday. Why did we put x plus 2? Even though it says negative 2. Remember, we want x minus h. So I need the opposite of whatever h is. So x minus negative 2 gave me x plus 2. And then I don't have a. I need to find it. But I am given another point. So what can I use that other point for?
1 for x.
1 is my x. 0 is my y. So remember, y is just my output, which is also f of x. So 0 is equal to a times 1 plus 2 squared minus 9. Right? Notice how many unknowns do I have in this equation now? 1. So what can I do? So I would end up adding, but the big picture is I'm trying to get these solutions. Yes, Jay? Yeah. Well, for vertex form, yes. That has not changed, right? That's the same formula we've used for vertex form since 2.5 weeks ago. I mean, yes, this is the equation for vertex form. That has not changed. We just have to recognize what h is, what k is, so that we can substitute it in. So it's not always going to be this, but it is always x minus h squared plus k. Right? With that a on the front. Is that coefficient? But here's what I want you to remember, like, y'all are starting to try to jump into steps, but we need to focus big picture. Conceptually, what are we trying to do? We're trying to find the solution. What are the 2 major things we can do to find the solution? Okay, so I can add, which is using an, starts with an I. So we're talking about adding here, right? That's using an inverse, right? I can use my inverses to create zeros and ones, and whenever I do one side of the equation, I have to do to the other. So I'm applying inverses. There's one other big picture thing that I can do. Instead of adding 9 here, what could I have done? What did I just do? It's an S word for this. Simplified. So when we talk about combining like terms, that's a simplifying process. When we talk about distributing, that's a simplifying process. We're simplifying there. Okay? Now, I did hear something, I'm glad somebody said this. Please be aware, I cannot distribute here. Distribution only works with what operation? Do you know? There's actually 2, because they're inverses of each other. Not with adding, but think about that bell ringer. Multiplication. You can only distribute with multiplication, and so you can distribute also with its inverse, which is division. You can distribute with multiplication and division. However, look at this right here. What's happening before this multiplication? What operation has to happen? So what's inside the parentheses, but what's outside that parentheses? Doesn't an exponent come before multiplication? I can't distribute then, because I have to do that exponent first. Be aware that you cannot distribute if you have that exponent, because the exponent happens before multiplication. So I'm glad someone brought that up, and please pay attention to that. That is a very common mistake that I see students make. You cannot distribute if there's an exponent there. That would happen first. Okay, but again, simplifying, inverses, those are the things I will remind you. What was my recommendation to do first? Do I simplify first, or do I use inverses first? I simplify first. Literally, guys, simplify tells you what to do. I'm making things simpler. That, like, you can use inverses first, Lily Pate, 100%, add 9 if you want. However, I want to make my life as easy as possible. And so I'm personally going to simplify first. What is 3 squared? So I've got a times 9 minus 9. There's nothing else I can simplify because multiplication happens before subtraction. Now I would add 9. Notice it's going to get me to the same spot. So can you use that inverse first? 100%. But I'm going to simplify first. And so 1 is equal to a. And now that I know a, I already knew h and k, so I can write this equation. What's taking the place of this a here? 1. Sorry, that was longer than I meant it to be. And y'all need to practice this, not just have me walk you through it, and we'll have whole class conversations about it. What I want you to do is I want you to go to your respective vertical surfaces. Let's work on 2 through 4. Remember, do you have examples somewhere that can help you out? Yes. But also, guys, please remember this. When you work at your vertical surfaces, the goal is not necessarily to just get the right answer every time. Yeah, we want to get there. But bigger than that, we need to understand what we're doing and why we're doing it. Because if you develop that conceptual understanding, even if you make a mistake now, develop that conceptual understanding of why we're doing what we're doing. That's going to help you get the right answer eventually. So focus on why. If you're sitting there and you don't know why someone in your group did something, what do you need to do? Ask a question. And if you hear someone ask a question, Ken, what are you going to do if someone asks you a question?
Try to answer.
You're going to try to answer it, right? And if you answered it, are you just going to move on and say, all right, they got it? No. Because have you ever had someone explain something to you and you not understand it the first time? And if you cannot explain it to the point where someone else can understand it, then you don't understand it as well as you need to, guys. So talk with each other. Talk the ideas out. Ask questions. And it's going to help you build the understanding that you need to be successful. We're going to come back together and try to, in about 10-15 minutes, to talk through these 3 problems. What are your questions before we get started about those instructions? All right, let's get up to our vertical surfaces. Let's start working on writing the equations for these 3 functions. Thank you. There we go, thank you. Thank you. Thank you all. Thank you, Preston. Thank you, Lily Kate. Thank you, Phoebe and Cam. The rest of group 1 just wants to ignore me, and all of group 5, it's okay. All right, so let's have a quick whole class conversation. Thank you, Shania and Jacoby. All right, so let's look at these problems. There's a couple of things that I want to address. Overall, we're starting to make sense of this. We're going to get more time during our whole class, or during the small group stuff at the vertical surfaces, but before that, I want to address a couple of details. First off, right here, you see in this group where they took the time, okay, vertex, and they labeled -6 as what? H. -1 is? Is that going to help us focus our attention on which formula to use? Is it going to help us identify what to substitute in where? Yes. And then if that's H and K, every time we have a point, in general, a point is which variable? Or which value? X and Y. Now, I will remind you, what could I use instead of Y? Not saying you have to write this, but what could you write? Well, which variable? Remember, f of x is just another notation saying if I have an x of -3, my output is 35. Okay? If you write those things above your points, it helps you focus your attention. And I highly recommend that. And then you can actually, and so I actually made this 2 steps. They just did 1 step to substitute in. And I'm going to, and so this is the work for number 4, right? I'm going to talk about numbers 2 and 3, a couple of small mistakes. But notice, what was the first step they took here? So they substituted in, right? There's my x, -3. There's my output, 35. H was -6, so it became +6. -1 became k. One of the mistakes that I am seeing, so hey guys, stop writing and pay attention to this. The conceptual, the understanding of why is what matters most. So focus on this concept. So many of us are forgetting when to switch the signs. When is the only time we switch signs?
In parentheses.
Inside the parentheses, and not just everywhere inside the parentheses.
Just
Not the input, it's the
R.
R1 and
R2.
R2 and H. It's because it literally says X minus H. So if I'm subtracting a positive, I get subtraction. If I subtract a negative, I get plus or addition. It's only when you subtract that you're going to get the opposite. Right here with K, I'm adding K. So whatever K is, it's a -1. If I add a -1, that just becomes subtraction. So it's only when you have the X minus H, the X minus R1, X minus R2, that minus something is when I'm going to get the opposite. That is a really important big picture idea. The other important idea that I'm seeing some of us lose sight of is this. Why can I solve this equation? It's important to get to this step before you start to solve. Why is it that I can solve that equation? Because I'm looking for A, but I saw some students say this. Why could I not solve that equation? I got 2 unknowns. I can't solve that equation with 2 unknowns, right? But if I have an input of -3, what's my output? 35. That's a big picture idea. I can only solve the equation with 1 unknown. And if I have an input of -3, I have an output of 35. I now have 1 unknown, now I can solve. Now, this is not the only first step. Remember that. And that's somewhere that a lot of us get stuck, is we're like, I have to memorize these steps. No, you don't. You have to understand that there's 2 major things you can do. What are the 2 major things you can do to solve the equation? What did they do first?
Right here.
They wrote the equation, but they simplified, right? When you go to solve, you can simplify. You have to be careful about how you simplify, but the big picture idea is that you can simplify to start that solving process. What's the other thing you can do besides simplifying? You can use, that's part of simplifying. Inverses. We want to create when we use an inverse, we either create a, what numbers are we trying to create? Zeros or ones. Notice they simplified first. That's my recommendation. 3 squared is 9. Now that I've simplified everything, I'm going to use inverses. Please do note this. This is not what I recommend completely. I do recommend adding 1. But what's the goal of adding 1? To create a 0. Every time you've seen me write this, I have put a line through it and I've written what above it? 0. Because it's not just randomly doing +1. I'm trying to pay attention to, have I created a 0? Because if you haven't created a 0, that's not going to help you. And then property of equality. Then I have 36 equals A times 9. And some of us are still doing division by 9. That's perfectly fine, but I will remind you, what am I recommending that you do?
Times 1 over 9.
Say it one more time for me.
Times 1 divided by 9.
Times 1 divided by 9. I remember, I want you to think through the 1 divided by 9, because I'm still dividing. This is called the reciprocal. It will always create what number if you multiply by the reciprocal? 1. The reciprocal will always create a 1. And I'm not creating a 0 here, but I am creating a 1. And I want to pay attention to that. Did I actually create a 1? In this case, I did. And a ninth of 36 is 4. Now that I know what A is, I'm going to substitute 4 in for A. Hold on one second, Tevin, and then I'll answer your question. Notice how they went back to the original equation. We have f of x, we have x. 4 is a, h is -6, so we get +6, and then we get -1. That's number 4. I'm going to talk through some details of numbers 2 and 3 in a second. But Tevin, what was your question?
What you do with that 3 right there?
What 3?
In parentheses.
This one right here?
Yeah.
Remember, I'm always trying to simplify first, or at least I am. What is 3 squared?
Oh,
What?
9, oh yeah.
That's where that 9 came from, right?
Oh, yeah.
So I'm using my operations to simplify that expression. Okay? You could have added 1 earlier, but I'm going to use I'm going to use the square to simplify my expression. Okay? All right. So that was the one that most of us didn't quite get to, but there is work for it to make sense out of it. Before I start talking about 2 and 3, what questions did you come across with numbers 2 and 3 that you did not get answered in your small group time, so that I can address them? Because if you don't have any questions, there's just some small details I want to talk about. So no questions came out of small group work? Making sense out of it? Seeing smiles all over the place? Almost like not all over the place, in a couple places, almost like we didn't fully understand it, but we're not willing to ask a question, so I can't answer those questions. Go for it, Sanaya.
How did it on?
How is what? The 35? Okay, good question. So when we say f of x, what that literally means is if my x is my input, this is the output for it. Well, the output is also known as y. F of x is the function notation for y. Does that make sense now? So remember we talked about function notation a couple weeks ago, and that's just the function notation for my output or for my y. So good question. Shania, did you have a question? What's up? About? I can't answer everything during whole class discussion. I'll come to the small group and talk with you in a second. If there was a specific question I could answer during whole class that I can't do. Okay, I'll come talk with y'all first afterwards. All right, so here's the only thing I want to point out. I need to come over to this work on the board over here. Right here. At the end with this group, we got -9 equals 1/3 times -4 plus 7 times -4 minus 5. Did they correctly find what A is? Yes. Do they correctly have R1 and R2? Yes, 100%. What's the issue though with this equation that we need to learn from? They did what?
Maybe we had to take out like stuff they substituted.
Remember, the goal is to find the relationship between my inputs and my outputs. I don't want this -9 here. That was just to help me find A. I don't want my -4 here, guys. The equation is f of x equals A times x minus R1 times x minus R2. This isn't the only group who did this. This is the only one who still had it on the board, so I want to talk about it for here. Remember, what are the 3 things we need to write that equation? A, R, well for this one, A, R1, and R2. X and Y, or X and f of x are variables. I need those variables still there. So f of x needs to stay there. A is 1/3. What was R1? -7, right? So x plus 7. R2 was 5, so the x minus 5. Make sure that you leave your f of x and your x there. This will give us a parabola that is concave up with what roots? -7 and a root of +5, right? So x-intercepts -7, 0, and +5, 0. That's the equation we wanted. Does that make sense? This will give us a 4, or this will give us a 4? Well, this is to show us how to get there. This would be a 3 plus or maybe a 4 depending on what you show. Not this, sorry. The work to get here would be a 3 plus or a 4 as long as you then get to this equation. Remember, the whole goal, guys, is to write the equation of a quadratic with these features. Right? Yes, Eliza. Y'all did that, didn't you? You weren't sure then? Okay. So they show their work here. It's a little small. So let me just start here. So we know, I'm trying to see if there's a couple up here. Let's look at it up here. So right here. This is the work for it, right? I'm going to show, remember here's the, nope, that's not that one. There was the x-intercepts -7, 0, and 5, 0, right? And so this was R1 and this was R2. So notice when they wrote this equation right here, they got x plus 7, because it's x minus R1, so you get x plus 7.
Why is Y like that?
Well, remember y is just another notation for f of x, right? So you can use f of x or y in that case. But are you good with the x plus 7 and x minus 5? Okay. So we have our roots, but we also need to find a, and so we had this point right here. Well, if we have a point, which value is -4 always? X. Or in a point, it's always x, and then it's y. So -4 is substituted in for x, -9 for y. And so notice, -9 is my y, -4 is my x. And then we just solve that equation. I'm going to write it a little bit bigger over here. I'm just going to solve that equation. So, my personal recommendation is to do what first? So, what are you trying to do inside the parentheses? You're trying to simplify, right? -4 plus 7 is 3. -4 minus 5 is? And I still can simplify a little bit more. That's a times -27. Are you good through here, Eliza? Okay, so we're just simplifying. Now I need to solve for a. What's the inverse of multiplication? Division. I use that reciprocal. You can just divide, but that's literally 1 divided by -27. If you just put this into the calculator, 1 divided by -27 times -9 is 1/3. It's just solving that equation once you substitute everything in. So you have to know your equation, your formula. You substitute your values in to find what a is. Okay? Remember guys, it's not just about having the final answers, it's about the understanding with it. So here's what we're going to do. For the last 10 minutes, or for the next 10 minutes, because we still have about 15 left, I want you to work on writing the equations for these parabolas that are on the back side. This one is going to require a little bit more thinking, but not a terrible amount. Look at that parabola. Actually, let's do this. I want you to take 60 seconds, stay within your small groups, talk about it within your group about which formula are we going to use to tackle writing the equation for this first parabola. So 60 seconds, start now. Talk about it within your groups. Make sure you can explain why. If you can't explain why, then you need to continue talking about it till you can. Every person in the group needs to be able to explain why.
We're going to be 2-0.
Yeah, so that increases 2x intercepts.
Yes, ma'am. Say it again.
I answered right. 3-0.
Yes, but can you go like during enrichment, or you can go right now?
Wait, oh my God. Here. Then, why is it?
I'll let you go the last like 2-3 minutes, but like I need to learn this stuff. Did that recap at all make sense over here? Can you talk a little bit more of that?
Yeah.
We're going to learn more about this. Okay, so we continue working with it here, so pay attention on this. Thank you. Thank you. Thank you. Okay. So I heard group 2 just a second ago saying, so it's not going to be vertex form. Why not?
Cause it give us both x-intercepts. Oh,
Hey,
my bad.
Ted's like, I got this one, Mr. King. Okay, but let's raise our hands to not talk over people because I have multiple people talking. I want to hear and respect each person's ideas. So, Tevin, I will say this. I was asking group 2, so let's let group 2 answer. So, Naisha, you have an idea here?
Yeah, the vertex really on a point, like in between spaces.
Okay, I'm going to come back to that in a second because that's really, really important. I want you to pay attention to this. So, Tevin, what was your reasoning?
My fault, I ain't even say
I know, you're good. But what was your reasoning?
I said it had two x roots.
It has 2 roots. We have 2 x-intercepts, don't we?
Yes.
So if I have my roots, I can use what form? Factored form. But Naisha is hitting on probably the most important idea. Do we know this exact vertex?
No.
No.
If we don't know the exact vertex, is it going to be easy to use vertex form?
No.
No. Right? I'm not going to use vertex form because I don't clearly have a vertex. I clearly have roots. So which form am I going to use? Factored form. Yes, Jalen. Which dot? Come mark it. I don't know which one. You can't say it right there. That is imprecise. Okay. So that's a good question. This is a great point. Could I mark that point?
I mean, yeah.
Yes. But if I'm talking about which form to use, is that point going to help me know which form to use?
Nah.
Because if I want to use factored form, I need what? The x.
I mean, x-intercept.
I need x-intercepts. That's why I marked these points. If I'm going to use factored form, I need x-intercepts. If I want vertex form, I need the, and that's why I marked this point. Do I know what that vertex is? No. Now, we'll point this out. Is it enough to know my x-intercepts to write the equation for this parabola?
We got a y-intercept.
Okay, we do have a y-intercept, but my question is,